Beast 13, you're being asked to find the general rule for the area of a polygon. You actually have done something like this in a previous activity where we were using a trapezoid and finding the area rule of this trapezoid. Notice the arrows. That's an indication that these lines are parallel, which is a requirement to be a trapezoid. In this activity, students came up with a rule that looked like this. And what they noticed, if they distributed the h, which represented height, into the parentheses, they had this same expression. It just looks a little bit different. Okay, so we distributed and ended up with this expression instead. And what they noticed, if you look at just one piece of these, it looks like the area rule for a single triangle. And in fact, that's what it is representing. So if our general rule for area of a trapezoid is made up of two triangles, where are those two triangles? Well, here's what they noticed. They could split a trapezoid into two triangles, this being one of the bases, and if you tipped it over, it could sit on this base also. And they also noticed that both of the triangles shared the same height. So when they came up with this rule and saw it in this way, it made perfect sense. We're going to do the same thing with our polygon. In the previous activity, we had a pentagon, a five-sided shape. And it's important to remember this is a regular polygon, so all the side lengths are the same. They noticed that in this pentagon, there were 5 congruent triangles. And they also knew how to find the area of a triangle. And they also noticed that in this particular polygon, they would then multiply it by 5. So they thought, how could I think about the number of sides of a polygon if it's not always going to be a pentagon? And they decided that n was a nice way to think about the number of sides. And then all they had to do was find the area of one of the triangles. Now, I encourage you to pause and use private reasoning time throughout this activity. So the first thing they said was, how can I rename B according to what's going on in my polygon? So with the pentagon, the B was made up of a perimeter of 300 feet. Remember, we were given that. 300 feet was the perimeter, so we'll use P. And they noticed that if the face, or the perimeter, was 300 feet, they could divide it up into 5 even chunks to represent the base of one triangle. So that's what they did. Now, our task is to pull these numbers out and realize that the perimeter isn't always going to be 300 feet. So what could I use instead of 300? And the number of sides isn't always going to be 5. And we've already talked about the fact that we could use n for the number of sides. So let's rename B with a general expression and put it back into the expression that we are building for the area. All right, now, having said that, we're now faced with finding the h, which is a little trickier, but one thing students noticed, which was very important, was that there was a central angle in all polygons, meaning if I stood in the center and turned all the way around, I've turned 360 degrees. So I can easily figure out what one triangle's angle measure is. And from there, they also noticed that they could split that triangle into 2 right triangles, which then is very convenient because we can use right triangle trigonometry. So given the fact that we know an angle and we know the base, all they needed to do was find the height of that triangle. Now, be careful. When you set up the algebraic statement, the height will be buried in there. you've got to algebraically separate the h out so that whatever is left can be substituted in for our h. Once you've done that, you have created the general rule for the area of a polygon.